Welcome to another Kstars focus tutorial. This one is on using FWHM, full width half maximum, as the focus measure. So I'm just going to start by doing a very brief recap of how HFR and FWHM are calculated in Kstars. So in order to do that, I pulled up a little graphic here on the right of the screen of a Gaussian surface in 3 dimensions. So for the purposes of this, just ignore the scales here, but imagine that the sort of the blue surface here represents your sensor. So you've got your 2 dimensions of the sensor going this way, and let's say top to bottom and left to right. And then the 3rd dimension of this graphic represents the intensity of the pixel at that particular location. So, if we imagine that this is a star with the peak in red, then further away we're just coming away to dark sky, if you like. So the way the HFR calculation works is it's quite simple. Having located a potential star, what Kstars will do is it will work out a theoretical circle that it could place over the center of the star, and by calculating the sum of the pixel intensities for all of those pixels that fall inside the star, it will calculate the circle for which the sum of the intensities inside the star is equal to the sum of the intensities outside of the theoretical circle. So having worked out what that circle is, it can calculate the diameter or the radius of that particular circle. And having done that, the radius is the HFR. So it's basically the radius of a circle that contains half the total flux of the star. So that's quite straightforward and quite simple, and Kstars, along with I think a lot of other capture software, performs that calculation, and obviously it's very robust software that's been around for a long time, so the calculations work well. Moving on to full width half maximum then. So the alternative way, or an alternative way of calculating the size of the star, is to try to fit a surface, a 2-dimensional surface, to the star profile as measured by the intensity readings on each pixel in your sensor. So I think the simplest way to do it is to assume that the star is Gaussian in shape and fit an equation that is a Gaussian equation to the data, adjust the parameters until the curve, or the surface rather, fits the measured profile as accurately as it can, and then you have the equation of the star profile. And you can use that calculation then to calculate the FWHM. Now the FWHM is pretty well. It's a self-explanatory acronym. So full width at half maximum. So the maximum is obviously the maximum intensity at the peak of the star. The half maximum is obviously half that intensity, and then the full width is the full width of the star at half its maximum intensity. So if you like, it's the diameter. I mean, this is circularly symmetrical, so you can think of it as the diameter of the circle that corresponds to half of the peak intensity. So it's just another way of measuring the size of the star as the star moves in and out of focus. So the width, the full width half half max, the width of the star will get bigger and smaller, etc. So coming back over onto Kstars then, you would expect that the HFR and the FWHM curves to be quite similar. They're in effect measuring the size of the star, but in different ways. So as you move nearer to focus, so the star becomes sharper and less bloated, and therefore its measure, either the HFR or the FWHM, becomes smaller. As you go through focus and the star starts to defocus again, so the measure starts to increase. So you get this V curve, where the minimum of the V corresponds to the point of optimum focus. So what I've done is I've solved, or I've run autofocus to solve the focus curve for a measure of HFR. What I'll do is I'll just take a quick snapshot of that, which we can use for comparison with the FWHM, which I'll run now. So as far as actually running FWHM, all you need to do is set the measure to FWHM. You'll notice you get this other field called PSF. The only option is Gaussian, so no need to worry about that. I think in future I might well add some other options in here, but for now it's just Gaussian. I've just reset the focus to where it was when I ran with HFR, just so we get a comparable result with FWHM, and then hit autofocus. So what's going to happen? The axis label has changed to FWHM. Kstars will still calculate HFR, but in addition, it will start calculating the FWHM, and the FWHM will be what drives this curve. So the HFR is really just for information, but the curve fitting process is being driven now by the FWHM. The other thing I suppose to note is that the values on the FWHM are, broadly speaking, double the value that you will see for HFR. They're not exactly, because the calculations are slightly different, but probably the way to think of it is that the HFR is a radius and the FWHM is like a diameter, which is obviously twice the radius. So as a rule of thumb, you can expect to see FWHM numbers roughly twice as big as the corresponding HFR numbers. So they won't be exactly, but it's a good rule of thumb. So if you're getting something that's a long way away from that, then that's indicative of a problem. So here we are. Kstars has solved on FWHM. The curve shape is very, very similar. The solution is one tick different from HFR. R squared is 0.99. You'll notice I took the refined curve fit off just so that we could see any discrepancies. I would recommend that you always run with it on, but I've taken it off because it highlights what I'm trying to do here, which is show you, differences between FWHM and HFR. I think the curves, you would probably agree, are very similar. There's probably not much to choose between the two. And certainly on my equipment, that's what I've observed when I've sort of run this during focusing sessions. I think in terms of running the FWHM, that's basically all you need to do. One other setting I'll just draw your attention to. By default, I think the convention is to display HFR numbers in pixels, and FWHM numbers are usually displayed in arc seconds. So you can change this display units, and it will change the units on the V curve if you wanted to, for example, have your FWHM in arc seconds rather than in pixels. when you rerun, basically it'll run the curve, not in pixels but in arc seconds were I to do that. I suppose just one other quick thing. I've basically loaded the in focus frame into PixInsight, and what I'll do is just solve the FWHM using PixInsight solver. So this little script here, FWHM eccentricity, is quite handy for this purpose. So I just played around with this a little bit earlier. I've set an upper limit of 0.9, so I don't include any saturated stars in the calculation. I've set the intensity relatively low. I've set the PSFs to be Gaussian, and if I run this, we'll see what PixInsight gives us. So PixInsight has given us 2.7 pixels as the median FWHM, and if I go back to Kstars, I've got 2.66. So it's it's not a million miles away. It detected more or less 642 stars and 634. So it's fairly close. I think if I played around a little bit more, I could probably get it to agree a bit more, but I don't think there's any value in doing that. It's simply to show you that the numbers it's displaying are probably ballpark correct. So I would say if you're interested in giving it a go, then just try it out, and I'd be very interested in any feedback. Thanks very much for watching.